Hello students, as we have started MCQs, in the last two lectures we have discussed MCQs of chapter number 2 and chapter number 3, 2002-2003 questions. You can say here we are starting MCQs of 2002-2003 based on chapter number 4, force, density and pressure. We have already discussed the theory of these topics. So if you want to go through the theory part, so you should go to those lectures which I have already uploaded. So here we have few questions based on 2002-2003 papers, you can say, and of course forces, density and pressure. These are the topics of this chapter. For the time being, actually, I have not uploaded the topic of density and pressure, but these two topics are very much sort of similar topics as you have already studied in your IGCSE or O levels. So it will not make a big difference. As far as this question is concerned, question number 13, which you can say will be question 1 for our sequence. A ruler of length 0.30 meter is pivoted at its center. Equal and opposite forces of magnitude 2 Newton are applied to the ends of the ruler, creating a consider is couple or torque of a couple is nothing but force, yani one of the forces multiplied by perpendicular distance from the pivot. So in this case, as you can see that we have two forces, these two forces in opposite direction, not acting at the same point, and of course they are equal forces, so they are basically giving us a couple or couple of forces. So as I said that the couple of forces can create a sort of torque of a couple, and what is the magnitude of the torque of the couple in this case on the ruler when it is in the as position shown. So this is what we have. So the basic point here to remember is, as we have discussed in theory as well, that you have to take the perpendicular distance. So either you will take the perpendicular force or you will take the perpendicular distance from the force. So here what we are doing, we are taking the perpendicular distance. So we can write that this is the symbol for perpendicular, so perpendicular distance. Ruler, this is the length of the ruler. So what we can do, this will be the perpendicular distance of the force. Like suppose if you have one force as 2 Newton, perpendicular distance will be this force. And what is the value of this particular component? So if you will recall the vectors thing, so if this is suppose a vector, or you can consider that if you have a triangle, so in this case ABC, even if you are not considering this as vector, ABC is simple. So this part is the perpendicular part, or the perpendicular in this triangle where 50 degree is the angle. So simple thing what you can say is 0.30 sine 50, this will give us the torque. And when you will multiply all these values, 0.30 multiplied by sine 50 multiplied by 2, you are getting 0.459, or simply you can say 0.46. And you know that Newton meter is the unit of torque of a couple. So simple thing is that C is the option here. And of course, as you know that we have applied a formula and the calculation we have. So of course these are the wrong answers, and only 0.46 will be our correct answer. But actually you have to recall the formula. As I said that if you are interested in theory, so you can go to the lecture which I have uploaded for these topics. And if you are new on this channel, so you should subscribe this channel to get new uploaded videos, and these inshallah will help you to understand the topic, and of course the MCQs we are doing here. And press the bell icon share, and of course your comments are also important for the improvement of the channel. Here, when you will go to the question number 2 in our sequence and 14 in this paper, a cylindrical block of wood has a cross-sectional area A and a weight W. It is totally immersed in water with its axis vertical. The block experiences pressure PT and PB at its top and bottom surfaces respectively. Which of the following expression is equal to the upthrust on the block? So what information you have? This is the situation. You have say a container, and here you have a block which is wooden block. For the time being it's completely immersed in water. So what they are showing you, that the upward pressure is or pressure from this side is PT top pressure, and from here you have PB bottom pressure. So you have to recall the force. So basically if you will write pressure, this will be force per unit area. So for the force, this is nothing but P into A. But you know that here we do not have any one pressure, but the difference of pressure, which is PB minus PT, will give us the resultant force, which is nothing but upthrust. So remember this thing, as I said, that we have not discussed in theory for the time being, but you can recall what you have studied in O level. Upthrust is the force which is of course upward in direction, and the result of your pressures, two pressures, bottom pressure and top pressure, and the difference of these two pressures, when you will multiply by area, you will get the result. So simple, again you can get the simple answer, which is C. And of course these are not the answers. Remember this thing, that here you have added W, here you have subtracted W. So of course there is no concept of subtraction or addition of weight in your upthrust thing. Similarly, this is nothing but only the pressure difference. So of course, as I said, that upthrust is a force, and force you can write in this way, and this is nothing but your answer C. So I hope this point is also clear. When you will go to question 15 in our sequence, we can say is question 3. So what they are saying here, the vector diagram shows three coplanar forces acting on an object at P. So here you have the object, and you can say and see that the coplanar forces, yani all these forces are lying on the same plane. Like suppose you have, this is your situation, x-axis and y-axis. So all these forces are lying in the plane xy plane you have here. So this is nothing but the situation of coplanar forces. Three coplanar forces means all the forces are lying on xy plane. So this is what we have. Here one thing is very simple. They are asking the magnitude of the resultant of these three forces is 1 Newton. What is the direction of this resultant? So simple thing is that you can calculate the resultant of these two forces, because these two forces are perpendicular forces, and you know that how you can calculate the result, which will be somewhere here. This is the Pythagoras theorem, which we will use. Hypotenuse square is equal to base square plus perpendicular square. So what is the base here? 4. So 4 square. What is the perpendicular? 3. So here you have the base, here you have the perpendicular. So 16 plus 9, which is 25. And when you will get the hypotenuse, this will be the square root of 25, which is nothing but 5. So here you can say and see that this force, which is the resultant force, will be equal to 5 Newton. So ultimately you can say that these two forces, 5 Newton in this direction, 5 Newton in this direction, and 4 Newton in the opposite direction we have, and ultimately simple thing is that we will have 1 Newton force in the direction of 5, because this is the larger of these two. So simple thing is that the direction of the force is required, but you have to do all these you can say sort of calculations, at this stage, but if you are, you can say, expert enough, you can calculate orally and you can get this answer, which is nothing but D. So this is your answer. Here you have the D answer because all these are not right, and you know that, as I have just explained. Here you have this 5 Newton force, and you know that this 5 Newton force is in this direction, which is of course in the opposite direction of 4 Newton. So where will be your resultant? Simple thing is 1 Newton resultant force is in the direction of 5. So this is the direction of your resultant force. So this is what we have as far as your paper 1 of May June 2 is concerned. Then we are going to here, which is the October November paper, and this is the October November 2. Here you have two questions, you can say two questions. Of course, here you have like question number 14 in our sequence, we can say is a question number 4. A uniform meter rule of mass 100 gram is supported by a knife edge at the 40 centimeter mark. So this is what you have. This is the position of the knife edge where your scale or your ruler is balanced, and a string at the 100 centimeter mark. Here you have the 100 centimeter mark, and here you have the string, and of course the string passes round a frictionless pulley and carries a mass of 20 gram. So this is the mass over here as shown in the diagram. At which mark on the ruler must a 50 gram mass be suspended so that the ruler balances? So here actually we have to consider 2-3 things. One is that we are talking about uniform meter rule. When I was discussing the topic, the theory, I have explained that if you have the uniform meter rule, the weight will be at the geometrical center, which is of course center of the scale. So here you can say that the weight of the scale is somewhere here. A meter rule of mass 100 gram. So basically what we are showing here, we are showing here the weight, but of course you know that if W is equal to mg, and even if you are using mass is giving you the force ultimately, which is of course like weight you have. So whether you are writing mass or you are writing weight doesn't make any difference. So weight is actually acting here, which is nothing but 100. If you want to write the weight, you can say this is something like 980, because if we are taking 100 gram, so this should be G will be 980, not 9.8, because 9.8 is nothing but meter per second square. But in this case, as we are dealing with gram, so of course this will be 980 centimeter per second square. So this is what we have for the weight. Okay. So here, as you can see that this weight is acting downward. So when this weight will acting downward, there will be a force which we have discussed in chapter number 2 and 3, and this is the tension which is in the opposite direction. So this is what we have, and you can see that this force will do what? If you have the upward force, then this force will try to rotate the ruler in anti-clockwise direction. So this is something which is very important. So what we can write, we can start from this point that the anti-clockwise moment is equal to what? So you can see that here we have mass of 20, and again the same thing, if you want to write in terms of the weight, you can write in this way, that it is something like this, and this is your weight. So this is the force. But for this force, what will be the perpendicular distance? So this will be the perpendicular distance. So this distance is nothing but 140. So 40 minus 100 or 100 minus 40 will give you 60. So when you will calculate, the result will be something like this: 1200 into 980. I am not using 980 for a purpose. But this will be your anti-clockwise moment. On the other hand, when you will consider this weight, so you can say that the clockwise moment is nothing but again 100 into 980, but this time what is the perpendicular distance? This is the perpendicular distance. So here you have 50 and here you have 40, so this is nothing but simple 10. So if you want to write, you can write in this way that here we have 1000 and 980. So what is the difference of anti-clockwise and clockwise torque? So you can say here we have 200. So 200 is basically the clockwise torque required. So where should be the clockwise torque? Of course down, somewhere here downwards, here or whatever the position, but it will be the downward force. So this downward force will generate a clockwise moment. So we have to find out that where should be the weight of 50 gram, so the ruler will be balanced. So simple thing is that, as you know, here we have the moment, which is nothing but force into length, perpendicular distance. So here what is the force? Force is this mass, or due to this mass. So 50 multiplied by 980, or if you are not considering 980, simply you can write 50. What is the moment? Here you have 200. So 200, when you will find out the value of length, so you will get 4. So this will be basically a big confusion here. You can write this answer as well, but this answer is not the correct answer. We have calculated the distance from the pivot, like here we have pivot, we have considered or we have calculated this distance L, but this distance L is not required. They are asking at which mark on the ruler must a 50. So where we will have this 4 from the pivot, of course the value will be somewhere here, and you can say that this value is the weight which we are hanging, 50 gram. Of course you can again go to the weight as well, but if you are just using this position, so this position is not 4, this position is basically 44. So be careful. Our answer will be C, not A. Of course not B, not D. But as you have calculated the length as 4, so you may have a confusion that answer is 4. Answer is not 4. The length you have calculated from the weight, which is due to 50 gram, you have calculated, and this length is telling you that the mark at which you have to hang or suspend the mass of 50 gram to take the balance situation will be nothing but 4 plus 40, which is 44. So 44 centimeter will be your correct answer. I hope it's clear. As I said, that whether you are using this 980 or not doesn't make any difference. Even if you are not using this 980 here, simply you can say that the value of the anti-clockwise moment is 200 and the value of clockwise moment is 1000. So here you can very simply calculate 1200 and 1000. The difference is 200, and then with the help of this you know that the clockwise moment is required, and you can calculate the length. And of course, as I said, that this length is not required, mark is required, and 44 centimeter mark will be your answer. So be careful of this confusion and this trick, because of which you can choose the wrong answer. So A is not right answer. Be careful. Then question number 15 in this paper, which is question number 5 for our sequence, you can say. The diagrams represent systems of coplanar forces, which we have already discussed. What are coplanar forces? Acting at a point, the lengths of force vectors represents the magnitudes of the forces. Which system of forces is in equilibrium? So you can see here that I have drawn diagrams just to save the time. Like here you have this vector, which is parallel to this one. Here you have this vector which is parallel to this one. So what you can do, if you will use the technique to draw the closed triangle, so take this vector back and somewhere here you are, and when you will draw the vector which is representing this force, you can say that we can draw it here or parallel to this one. So ultimately you can say and see that one force here we have, another force is here we have, and then we have a closed triangle. All other are not giving you this behavior, so B, C and D are not right. Only the correct answer is A. As you know that this they are mentioning here, the lengths of force vectors represent magnitude of the forces. So it means that you can see here that this magnitude and this magnitude, or this length and this length, and this vector which they have given and this resultant which we are getting are not of the same magnitude. Same is the case here and same is the case here. So they are not giving you the concept of closed triangle which is required for a system in balance or in equilibrium. So be careful, you have to draw a closed triangle, and which is giving you the closed triangle? Nothing but A. I hope this will be a clear concept here. Fine. So these are the two questions from paper, your October November 2. Now we are going to your October November 3. So here we have these two forces or concepts. So question number, you can say 13 here, but for our sequence it will be 6th question. The diagram shows 4 forces applied to a circular object. You can see that these are the forces here. Which of the following describes the resultant force and resultant torque on the object? So simply they are asking that what is the situation, whether the resultant force is 0, resultant torque is 0 and so on. So simple thing is that from where you can start, like resultant force. So this 30 Newton force is balancing this 30 Newton force. So as far as your vertical forces are concerned, they are balancing the effect of each other. So the resultant or summation Fy is equal to 0. But on the other hand, you can also see that these two forces are in the same direction. So summation Fx is not equal to 0. So the resultant forces are not 0, but they are non-zero. So what you did, you have already rejected these two options, because when you are starting the concept of resultant forces, you have just observed that resultant of summation F is not giving you 0. So of course is the non-zero situation. So forces are non-zero. But here you have two other options, like resultant torque is 0 or non-zero. So what you can say here, that as far as these two forces are concerned, like 20 Newton force is giving you the anti-clockwise rotation or moment, and the this force is giving you the clockwise, sorry, this is giving you the clockwise and this is giving you the anti-clockwise moment if you have this point as a pivot. So what you can say, that the summation of tau is equal to 0 for these two forces, for forces of 20 Newton, tau is equal to 0. But when you will consider these forces, you can see that the 30 Newton force is giving you the clockwise rotation, and this 30 is also giving you the clockwise rotation. So for forces of 30 Newton, you can write that tau is not equal to 0. So not your force, any resultant force, not your resultant torque is equal to 0. So neither of these two, simply you can say, are 0, and simply because of this you can reject this point C or option C. So only option remaining is D, which shows that both of these, any resultant of forces because of this situation and resultant of torque because of these two forces, are giving you the clockwise rotation. Both of them are giving us non-zero. So the option is non-zero. Both these are non-zeros. So be careful. Here, as far as question number 14 is concerned, we can say the question 7. A balloon is acted upon by three forces: weight, thrust, and sideways forces due to the wind as shown in the figure. So you know that up thrust is 10,000, weight is 9,000, and sideways forces are 50 Newton. So simple thing, you can say that here we have x-axis, here we have y-axis situation, or horizontal and vertical forces. So this is the situation given. What is the question? What is the vertical component of the resultant force and the balloon? So simple thing is that vertical component is 10,000 upward, 9,000 downward. So simple thing is that the difference of these two will give you the resultant force on the balloon vertical component. So simple thing is that here we have 1000. So simple answer is B, not A, not C, not D. So this is what we have. Even if you will consider the lengthy component resolution and everything, you will get the same answer. So simple thing is that we need a quick solution of your problems as far as the MCQs are concerned. So this is simple, that here we have the vertical force of 10,000, downward force is 9,000. Just subtract these two and you will get the result. So this will be your vertical component of the resultant force on the balloon. I hope it's clear. Then here you have a very important question, and question number 8, you can say, a ball falls from rest through air and eventually reaches a constant velocity. Eventually reaches a constant velocity passing through air. Falls from rest. So all this information you have. For this fall, forces X and Y vary with time as shown. What are forces X and Y? So simple thing is that when you will recall the motion of a body through air, you can say that when initially the body, suppose you have a ball, when the ball will fall initially, it will have a downward force, which is W. But with the passage of time, what will happen? The air friction will increase, and because of this air friction or air resistance, the resultant force, if you have this result, the reaction or friction force, or I can write air resistance here. So the difference of these two, W minus F, this is your resultant force. I can write R for this, and here we will see that which will be the resultant force and what is the situation of the resultant force. So ultimately what we can say, that the resultant force is decreasing with the passage of time, and at what point your weight will be equal to the air friction, and what you can say that at this moment the resultant force will be 0 or approaches to 0. So simple thing is that you can say that what is happening, air resistance is increasing but with decreasing rate. Why? Because with the passage of time, the air friction will decrease, because the velocity of the body will ultimately slowly and gradually is getting a situation which is approaching to constant velocity, means decreasing. Yani the initial velocity is at this stage, or at this stage I can say the velocity was maximum, but when you are going down, velocity is slowly and gradually decreasing, and at one point it becomes constant. At what point? So simply you can say that at this point where the air friction becomes equal to the weight. So simply you can say that air friction is decreasing, increasing but with decreasing rate. So this is the situation of increasing and decreasing rate. So simple thing is that your force X is nothing but air resistance. Upthrust, there is no question of upthrust here, because upthrust is a sort of constant force which is not depending on anything but the volume of the you can say fluid displaced by a body. So these two options C and D you have already rejected, or you have to reject these two. Now you have options A and B. So what I said, that what is the situation in A, you have both air resistance and resultant force. In B, you have air resistance but weight. And you know that when you are falling from some, you can say close to the surface thing, there will be no change as far as the weight is concerned. So this is not possible situation for weight, yani weight is decreasing, weight is not decreasing. Only the resultant force is decreasing, and as I said that it will be somewhere close to zero at one point. But for the timing, at least we can say that the resultant force is decreasing. So B is not a correct option. Only the option remaining for us is A. I hope everything is clear. I repeat, this force X is the friction, air friction, which is increasing with the decreasing rate. And of course, when the force is decreasing, you can say that the situation is that the weight is not decreasing, but the resultant force is decreasing. So the force, air friction is increasing, but resultant force is decreasing. So this is the explanation of this question, and because of this we are considering, or actually this is the answer what we are considering. This is the answer A. And as I said that if you are new on this channel, subscribe this channel, and of course you will get the new uploaded videos as soon as I will upload the new things. And to get the theoretical part of these questions, you have to go through my previous lectures based on or chapter 4 and forces and all these things. Okay, so here what we have discussed, this was the question number 8 for us. So we can say that this will be question number 9 for the sequence. A spanner is used to tighten the nut as shown. A force F is applied at right angles to the spanner at a distance of 0.25. This is the distance given from the center of the nut. So here you have the pivot. This is the pivot, you can say. When the nut is fully tightened, the applied force is 200 Newton. So this is the situation here. Any maximum torque which you can produce is nothing but 200 multiplied by 0.25. So this will be the maximum torque which you are producing to get a complete tight nut. So this is nothing but 50 Newton meter. What they are saying, what is the resistive torque in an anti-clockwise direction preventing further tightening? So what is the situation here? This is the force you are applying, and you are getting this clockwise moment. And if you want to get the anti-clockwise moment or torque, this will be because of the resistive force. So of course this will be same as this one. If you want to get this situation, what situation? Preventing further tightening, yani at this stage your resistive torque will be equal to the torque because of your applied force, which is nothing but 50. So this will be your answer. It's a very simple, straightforward calculation. So of course the other options are not right. Then question number 10. Here again a very simple thing, I think. Two parallel forces, each of magnitude F, act on a body. What is the magnitude of torque of the body produced by these two forces? So first of all, as they are saying two parallel forces, each magnitude F means equal magnitude, parallel forces, opposite in direction, as you can see. So this is nothing but couple. They are not acting at the same point as well. So basically this is nothing but couple. And you know that when you will talk about the torque of a couple, this will be one of the force multiplied by perpendicular distance between the forces. So this distance between the forces is not perpendicular distance, of course. So you cannot say that this is FD. 2FD is absolutely wrong, because we have to consider only one force. So it should not be 2. Over here 2FS, again as I said, both of these forces we need not to consider one of the forces, multiplied by perpendicular distance. So if this force, suppose F, and the perpendicular distance is S, so option is nothing but Fs. Same is the case here. If you will consider this force, here you have this force, and you can say that this is the perpendicular distance, and I have already explained these things in theoretical part. Then you have to take your force back somewhere here, or in this case you can get the perpendicular distance easily. And of course the perpendicular distance is telling you that one of the force F and the perpendicular distance is S. So as I said, this answer is simple, Fs. You need not to go for any further detail. So this is question number 10 for our sequence, but this is question number 14 of your October number 3. Here you have another question which is basically very simple but very you can say logical and conceptual based. So that's why it's very important. A force F is applied to a freely moving object. At one instant of time, the object has velocity v and acceleration a. So all information you have, F, velocity, acceleration, everything. Which quantities must be in the same direction? So simple thing is that you can recall Newton's second law of motion, which says that F is equal to ma, and simple thing is that acceleration is directly proportional to the force and in the direction of the force. So must condition is only for this situation, that A and F must be in the same direction. Velocity and acceleration is not necessary in the same direction. Of course, the velocity and force again not necessarily in the same direction, because suppose force is acting here, your resistive force suppose, and the velocity is in this direction. So there are other possibilities as well. So A, C and D are all wrong options for this must condition. You can say they are right, but for must you need not to you can say have this situation of A must be in the same direction of V, or V must be in the same direction of F, and V, F and A must be in the same direction of A or in the same direction. But remember one thing, that either F will be in the same direction of A, or A will be in the same direction of F, or acceleration will be in the same direction of change of velocity. So these are two possibilities, but as far as this question is concerned, we are only talking about the must condition, so be careful. This question 12 is again very important questions, and they can ask you these type of questions very frequently when you are dealing with the first condition of equilibrium or second condition of equilibrium. Here a hinged door is held closed in the horizontal position by a cable. So here you have a cable, and here you have the other forces, like the door has a weight which is acting downward and hinged in the reacting or contact force from the wall. So these are few forces. Three forces act on the door: the weight W of the door, the tension in the cable, and the force H at the hinge. So this is what we have. Simply, as I have already done actually here, you can resolve your forces. Weight of course is simple, downward, acting downward, but as far as the T is concerned, you can resolve this T into your you can say a Y component and X component, and similarly you can resolve your H into your Y component and X component. Here what you can say and see, that Hx, any horizontal component of hinge, will be equal to horizontal components of T5 for a balanced situation. But when you have the situation of the vertical component, so Ty is the upward force and Hy and W are downward forces. So if you have the situation of a, you can say held closed in a horizontal position by a cable, yani in a stable condition you can say, or in the equilibrium position. So what will be the situation? Ty will be equal to Hy plus W, and Simply you can say that if you will consider say Ty, so this will be of course greater than W because you have another force which is Hy. Similarly, you can say that Ty will also be greater than Hy. So simple thing is that Ty is greater than W. This is one thing. On the other hand, if Ty is greater than your Hy, then obviously the T will be greater than H, yani horizontal, the hinge force, not horizontal. So this is hinge force basically. So simply we can say that what is the minimum force? W. What is the force greater than W? H. Because you can say and see that here you are going to add these two forces to get this Ty. So ultimately your T is the greatest force or largest force. So increasing order will be like this: W, H and T, which is nothing but your option C. I hope you have understood what I have explained. Simple thing again I am repeating. And what is the situation? Ty is equal to, as you can see that there is no vertical movement. Ty is equal to Hy plus W. So it means that Ty is greater than H, as well as it's greater than your value W. Like suppose you have 5 is equal to 2 plus 3. So of course 5 is greater than 2 and is also greater than 3. So it means that we have to consider that which one is the minimum. So for this we can simply say that the vertical the force only is W, which is the minimum. On the other hand, you can say that the force H, any the contact force from the hinge, has a component here as well, of course. So this will be greater than the simple weight. Yani hinge is greater than W, but T or this T is greater than H. So this will be the sequence W, H and T. And simply you can say this will be the simple logic and calculation for it. Basically it's not a calculation here, we are just giving a logic reasoning and we are getting the correct answer, which is C. I hope you have understood what I have explained. So as I said earlier that if you are new on this channel, subscribe this channel and press the bell icon so you can get the new uploaded videos immediately. And these videos must be and will be inshallah helpful for you. And if you feel that they are giving you any help, so share and give your comments as well, so other students can also get benefit of this set of videos. So take care of yourself and be happy and be ready for your exam. Till the next lecture, Allah.